In this problem, we're going to learn how to deal with problems of torsion where two sides of the torsional bar are fixed. I hope you enjoyed this tutorial with Murumai. Let's go forward with that tutorial. Thanks.
Is that now this rod is fixed from both ends. So there is a 5 Newton meter here. There is a distributed torque here. This is B, C. So now you know that phi A equals phi C equals 0 because it's fixed. But you don't know what TA and TC are. There are two variables right now. There is initially you just did a force balance, you got what TA was, but now you have two variables. So you have TA. I'm just going to. So this reaction forces I'm using, it doesn't really matter what signs I use. Sorry, I'm just. This TA, TC. This is going to be 1. The total is going to be 5. So I have TA plus 6 equals TC. Doesn't really matter what sign convention I use, as far as when I apply the formula, I should take care of what the conventions are or what the directions are. That's it. So TA plus 6 equals TC. So we have one equation in TA and TC. We still don't know what TA and TC is. What we know is that if you go from either end of the rod, right? If you start from A and go to B, or if you start from C and go to B, the phi value that you get should still be the same because B is 1 point, right? It doesn't really matter which side you calculate it from. So the one thing we know is that the for the geometric compatibility to satisfy, TA and TB should, phi B should always be the same regardless of whether you calculate it from one end or the other end. So let's see how we can do that. I'm not going to go into the numbers for this one, but I'm going to give you a picture of how that can be done. So there is this torque here. So let's look at our points again. There is A, E, sorry, A, there is A, D, E, B. Then we have this. There is a F here, and there is a C. Okay. So now let's try to find phi B from this end. So what do you do for that is you look at the first section, right? AD, very similar to what we have done so far. So we have a TA here. We still don't know what the value of TA is. It's just a TA. And there is a torque T. So that implies T equals TA, right? Correct? Let me know if the calculations go off hand again. So there is phi DE equals TA by this is, what was it again? 10 centimeters? Okay, 10 centimeters into 0.1 by J1. This is 1J1 for this, J2 for this. So we still don't know what this is. We just know that it's some TA. It's some function of TA. Okay, now we go ahead. We look at DE section. So there's phi DE. And we again do the integration. So there is, let's look at the rod first. There's the force, sorry, the torque, the distance L from D. So this is TA. So we have T equals 10L plus TA. So phi dE equals integral TA plus 10L dl. I'm going a little fast on this, so stop me if at any point you don't understand what I'm doing. So L goes from 0 to, what's that, 10 centimeter again, so 0.1. So we again have something, again a function of A. So now we know that phi A is 0. So this was phi AD, right? My bad. This is a correction, right? This is phi AD. First part, this is phi DE. the second part. So phi A is 0. So this gives you what phi D is. And then this gives you what phi E is from that. And that is in a function of TA. You still don't know exact value. It is because TA is unknown. So you get it as a function of TA. So moving ahead. Just a second. Okay. So now that you have phi E as a function of TA, you move ahead and you find out what phi B is, right? So there is E, this is D, this is A, TA. There is the distributed torque here. I'm making a cut between E and B now. So section EB. I follow the same procedure. This will give me T equals TA plus 1. I put it in the equation. I get PE equals TA plus 1 into whatever that L is. I think it's 0.08 upon GJ1. So I know what phi E is. So now I get phi B. So I get phi B as some function F1 of TA. Is up till this point the process clear? So now I have phi B as a function of TA. So I need an equation between TA and TC. I have one equation between TA and TC which started with the initial force balance. If I can find one more equation between TA and TC, I can solve the set to get what TA is and what TC is. And the major thing in that is that the important part is that phi B is going to be same either way. You calculate it. So let's try to calculate phi B from the other end now. So I'll take the rod. There is this rod like this. So there is this 5 Newton meter here, which is F. This is B. And this is TA. This is A. So now what I'm going to do is I'm going to look at FC, the section FC first. I'm going to try to get phi B from the other end. So if I look at section FC, if I make a cut here, and I look at that cut, torque in the direction of the normal, right? So torque is going to be like this, T. And TC, whatever direction of TC I've initially chosen. Try to stick to the same. You can choose these randomly, these directions of TA and TC, but try to stick to them so that you don't make any sign mistakes in your calculations. This is TC. Okay. I chose these randomly, so I'm going to just stick to those. So it's TC, so I have TA, sorry, not TA. I have this torque in this section, which is TFC, now equals TC. So phi FC equals TC into what is this? This is 10 centimeter. This is 8 centimeter. Okay. This is 10 centimeter. And this is 8 centimeter. Into 0.1 by G into J2. Now it's the different diameter. It's a different J. So it's J2. And that equals phi F minus phi C. So phi C is 0 because phi C, the point C is fixed again. So now you have got phi F in terms of TC. So now let's look at the part BF. Now if I make a cut here, very similar to what I've done, just I'm doing the entire thing from the other side of the rod. So there is 5 Newton meter here, and there is a T here, again in the direction of the normal. So this is T, this is 5. Sorry, this is TC, this is 5. So T equals, that'll be TC minus 5. And that gives me BF equals TC minus 5 into 0.08 upon GG2. I know what phi F is, so now I know what phi B is. Phi B is, this is phi B, phi F minus phi B. Phi F minus phi B. So, so again, if this, notation wise, what you write, if it's phi BF, phi FB, as far as you have understood what you are writing and you have mentioned what you are writing, that's fine. Okay, just stick to whatever you are writing. Don't keep on changing your notation throughout your solution. So it's just confusing. So phi BF, so it's phi F minus phi B. So phi B, I know now in terms of TC because I know phi F. So is this part clear? So now I have phi B as a function of TA. So I'm just going to do F2 TC. So now, since phi b, regardless of where you solve it from, it's going to still going to be the same. So we have f1 ta equals f2 tc. So these functions you know, right? You have calculated. There's going to be numbers and equations and stuff like that. So now you have this equation in ta and tc, and you have the original force balance equation, right? So what was that? Ta plus 6 equals tc. So solve for ta and tc, so you'll get both the reaction forces. Put them in either of these, and you'll get what phi b is numerically. Is this part clear? Yeah, you just solve the simultaneous equation. TA and TC, it wouldn't be like it will still be first order equations because the way you have got it, there is no, you have not, powered TA or TC anywhere. So it's going to be just first order equations, so it'll be easier to solve the simultaneous equation. Go ahead. Yeah. 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 So, and the way I'm looking at it is we look at the rod from negative to the positive end. So it's like along the axis. The notation you're saying? The way I have used it throughout the solution is like this. So I just stick in that. Yeah, correct. So as far as you can like hold on to the sign convention throughout, right? So you have hold on to the same sign convention for T. So you can do phi BF equals phi F minus phi B. So that works. You're not changing the no, you're not changing the coordinate system anywhere, right? So the coordinate system remains fixed. You're just looking at it differently. Yeah. So it's phi F minus phi B, right? So I'm looking at this rod, for example. Correct. So I'm looking at this rod. I would have generally done that. Okay, this is the T here, and this is phi B. This is along the axis, for example. So this minus this. So what I'm doing, yeah. So what I'm doing right now is I'm doing this. I'm looking at the torque here, but it's the same. It's the same rod. I'm just looking at it from a different side, but it's still the same rod. So if you maintain the sign of T, you maintain the sign of phi BS. You just stick to that. Is that clear? I just didn't want to change the formula again and again, so I just use the same formula. So is this part clear? Anybody on Zoom has any doubts? I really want you guys to actually solve this step by step. And I think I have the numbers somewhere. So in case you guys drop by in the office hours, if you want to check your numbers, you can do that with me. So try to solve it because it gets you solving the same formula multiple times, and you look at the sign conventions, you look at everything else. And if you have your own, this is the way I understand science and the way I do it. If you have your own intuition, mostly what you do in forces is you look at intuition, right? You feel it's twisting in this direction, so the twist is in that direction. So if you have your own intuition, that's fine as well. Don't be afraid to use that. Just mention it what you are using and you're good, because sign convention is the main reason of that is to understand, make others understand what you're doing. So if that is achieved, then you don't have to worry about the sign. But this is the way I remember it, and I'm hoping that'll help you as well. So try to do this problem from the scratch. Try to do both of the problems and get the numbers, drop by in the office hours. Maybe we can discuss the numbers if you want. So that is it for the torsional part of today's discussion. So if anybody has any questions with this or any part of the theory, we can go over that before we move on. I have one problem with chord beam with me today on the agenda. So before that, so if anybody has any conceptual questions or anything related to twisting or torsion, you can ask me right now.